Today we'll be working on a problem. Let X be a metric space. E and F are two disjoint closed subsets of X. The question is, can we find two disjoint open sets U and V of X such that U contains E and V contains F? You can pause the video if you want to think about this problem. Okay, let's work on this. The answer is yes. Here is why. First, let's see, we have the metric space. This is E and this is F. So looks like, from the graph, we want to find uh, open set U and open set V disjoint. So because X is a metric space, and then from this graph, if we look at like every point in the U is not, it has some distance, non-zero distance away from F. And for any point in this V, also the distance is a positive. So this observation led us to define a function. Let's define a function f from this metric space to the real numbers. And here's the definition. F of x is the difference distance from x to this closed set E minus the distance of this x to F. So where we know this x to E basically is the infimum of all the distance between x and E, where E is in this set. So this distance is the distance for this metric space. So we know that distance function is always continuous, right? So this and then the distance from x to E, this function is continuous. And then similarly, this the distance from x to F is also continuous. So F of x is continuous. And then also we have like we know that x any point because E is closed. Okay, here's the E. For any point outside of E, we know there is a open ball with delta. So there exists delta greater than 0 such that this ball centered on the x with radius x with the radius delta is contained in the complement of E, which is open. So this means, which means if X is not in E, the distance from X to E is greater than 0 because this is greater or equal than this delta and greater than 0. Okay, so now we combine all of this. Let's define so what U is, right? So from this U, let's define to the pre-image of from minus infinity to 0 and V, the pre-image of 0 to infinity. We know that because minus infinity to 0 and the 0 to infinity, these two open interval are disjoint. So U and V are disjoint. And for all x in E, f of x is what? Is minus the from x to f. And as we know that from what we it just proved, right? So if any point outside of this closed set, the distance is greater than 0. So this one is less than 0, which implies x is in U. And similarly, for all x in f, f of x is the distance from x to E. Because E and F are disjoint, so x in F means x is not in E. So this one greater than 0. And then this implies x in V. So we find two disjoint, and this is clearly open, right? Because it's the pre-image of open set. So U are open and V are open, and they are disjoint. And then U contains E, and V contains um, F. And that's it. So the answer to the original problem is yes.